All right, welcome. Today we are diving into something, well, it's pretty wild. We're exploring a radical theory that asks a crazy question. What if one of the most fundamental constants in all of mathematics isn't quite finished?
So let's just get right into it with a question that honestly sounds kind of nuts. What if the value for pi, the number we all memorized in school, the absolute bedrock of circles and spheres, is actually wrong?
So, according to this theory, the version of pi we all use is only, get this, 99.9985% accurate. Now, yeah, that is incredibly close, but the whole idea here is that this tiny, tiny difference isn't just some rounding error. No, it's the key to unlocking a totally new way of looking at the universe.
Okay, so how on earth can something we think of as perfect, as fundamental as pi, have a flaw? Well, the source material we're looking at claims the problem isn't really with the number itself. It's more about how we understand what it even represents.
It all starts with something super simple, an image we all get, a perfect circle sitting right inside a perfect square. If the square's area is 4, the circle's area is pi. But here's the twist. The secret isn't what's inside the circle.
Yeah, what's really fascinating here is that this theory zooms in on the parts we usually just ignore. Those 4 little corners left over. It calls this the remnant area. And the big idea is that this isn't just wasted space. It's a super significant value that holds a secret connection to another famous number.
And yep, that famous number is the golden ratio, or phi. You know the one. It's everywhere. It shows up in the spirals of galaxies, in seashells, in the proportions of ancient buildings. It's basically the universe's blueprint for growth. So keep phi in your head, because it is about to become a huge deal.
All right, let's move on. Let's look at the brand new constant this theory proposes and see how it supposedly connects that leftover corner space with the geometry of growth. And this quote really nails the core idea. The theory puts forward this brand new constant. They call it zk, and it claims that zk is the missing piece of the puzzle. It's the constant that perfectly describes the relationship between that remnant area in the corners and the golden ratio, phi.
So, the important thing to grasp is that zk isn't just some random number they pulled out of thin air. It's defined as this really fundamental ratio. It's supposed to be the exact value that links the geometry of that leftover space to the principle of growth that phi represents.
And this is where it gets really radical. This new relationship gives us a totally new formula for pi. So instead of being this infinite, kind of mysterious number, pi gets redefined as a simple equation. The area of the square, which is 4, minus that remnant area, which is now just zk times the golden ratio. Wow.
Okay, but wait a minute. This kind of feels like cheating, right? Like, do you need to know pi to figure out z, which then gives you pi? Well, the theory says no, you don't. It actually suggests a way to calculate what it calls a golden pi from scratch, using only the golden ratio.
So here's the 4-step recipe they propose. First, you define zk using this totally new formula. And notice, there's no pi in it. It just uses the golden ratio and a couple of simple numbers. Second, you punch that into a calculator and get the value for zk. Third, you take that zk value and plug it back into that new formula for pi we just talked about. And what you get is what the theory calls golden pi. And here it is. This is the moment. On top, you've got our official pi. And right below it, the golden pi that was cooked up using just the golden ratio. I mean, just look at how close they are. They are astonishingly close. We're talking 99.9985% identical. The difference is just, it's almost nothing.
All right, so you're probably thinking, okay, that's either an unbelievable coincidence or something. But it's still not the same number. So why on earth would this tiny, tiny difference even matter? Well, this is where the theory argues the gap is where pure math stops and the physics of our actual reality begins.
And hold on, because this is where we jump from pure math into some pretty mind-bending physics. The theory says this mathematical gap isn't a mistake. It's a warp factor that actually accounts for the fundamental curve of space-time itself. And if that's true, it could change how we measure the universe's ultimate speed limit.
Okay, so think of it like this. The theory says our official pi is perfect for math on a flat piece of paper. That's Euclidean geometry. But it argues that the real physical universe isn't flat like paper. It's fundamentally curved. And it claims that this curve is defined by, you guessed it, the golden ratio. That would mean real-world physics actually runs on this slightly different physical pi. So could this be why we have to keep adding these little fudge factors into our physics equations? I mean, we all know GPS satellites need those constant adjustments for relativity, right? Their clocks run at different speeds. But what if part of that correction is actually us trying to force the math of a flat universe onto a reality that's actually curved?
See, the thing is, pi is baked into so many fundamental physics equations. So if you change pi, even by a tiny bit, things start to change. And when this golden geometric correction gets applied to the math that defines the speed of light, this theory calculates a new true speed. And it's over 4,500 meters per second faster than what we currently measure. Whoa!
But it doesn't stop at the speed of light. The implications go way, way deeper. The final, and honestly the most profound claim here, is that this zk constant completely redefines our understanding of energy and chaos itself.
So, we all know E equals mc squared. The squared part means it's based on a square. It treats energy potential like a flat 2D area. But this theory argues that energy doesn't expand in a square, it expands in a sphere, right? So, it proposes a new formula, E equals mcd. And D isn't just some letter, it represents a dynamic, curved potential for energy, one that's directly tied to this new golden geometry.
And this leads to maybe the most stunning idea of all, a complete rethink of entropy. We usually think of entropy as randomness, decay, the universe slowly fizzling out. But in this model, entropy is that geometric remnant. It's not chaos at all. It's that leftover energy from the corners of the square. It's the fundamental price of curvature, the cost of having a curved circular reality exist in the first place. I mean, this quote just nails it. The reason we don't notice this supposed error is because all of our measuring tools are built on the same flat geometry we're trying to measure. It's like we're measuring a curved room with a ruler that's also curved, and then we're surprised when we conclude the walls are straight.
Okay, so let's be clear. The point of this explainer isn't to say that all of mainstream physics is wrong. Not at all. It's really to explore a fascinating what-if scenario. It's a thought experiment that connects pi, the golden ratio, and the laws of physics in a way that is, you have to admit, pretty creative and thought-provoking.
And that leaves us with one last big question to chew on. If the very geometric language we use to describe reality is even just a tiny bit incomplete, what else might we be getting wrong? What other fundamental things are we looking at and thinking are straight, when maybe, just maybe, they're curved?